Hello everyone, my name is Teacher James and welcome to Maths with Teacher James. In today's lesson, we are going to look at the rules of indices. This is Maths for Mathayom student, Mathayom for student. Are you ready for today's lesson? Are you excited as much as I am? Let's look at today's lesson. Let me share my screen so that we can start with our lesson for today. But before I do that, I want the student to listen to the teacher, okay? You listen to the teacher, you look at the teacher, and perhaps you answer the teacher. Are you ready? Okay, let's start. Let me share my screen. Okay, student, this is my share screen. Our lesson for today is rules of indices. Let's look at rule number 1. This is the first rule of indices. Look at this. This is an index equation. We have a raised to the power m times, right, times a raised to the power n. When the bases are equal, when we have equal bases, when the bases are equal, we add the powers. We add the powers. So in this case, a raised to the power m times a raised to the power n is equal to a raised to the power m plus n. This is rule number 1 in indices. Okay, now let's look at rule number 2. Look at this, rule number 2. We have a raised to the power m divided by a raised to the power n. In indices, when you are dividing and the bases are equal, when you're dividing and you have equal bases, you subtract the powers. You subtract their powers. So in this case, a raised to the power m over a raised to the power n is equal to a raised to the power m minus n. I'm not sure. Good. Minus m. Okay, let's look at rule number 3. The third rule of indices. When you have a raised to the power m in brackets, in parentheses, multiplied by n, right? This means you are multiplying whatever is in these parentheses or in the bracket by whatever power is raised on. We have the basis a. Okay, so in this case, we multiply the power. So the right answer is a raised to the power m times n, right? Which is equal to a raised to the power m n. That is the right answer. This is rule number 3 in indices. Let's look at rule number 4. Rule number 4. When we have in parentheses a, b, can you see the bases are different? We have a and b, different bases. All of this raised to the power m in indices. We have to do a. Let's expand. You multiply whatever is in this bracket by m, okay, by whatever the power is. The bases are not equal, so we say am times bm, okay, which is equal to a raised to the power m times b raised to the power m. The dot means multiplication. That is the final answer. And this is the 4th rule of indices. Let's look at rule number 5. Rule number 5. Look at this. We have a raised to the power a over a divided by b in parentheses or in bracket raised to the power m. In indices, this is rule number 5. In indices, we say a m a raised to the power m, you are dividing it by b raised to the power m. Remember, the bases are not equal, so whatever is in the parentheses, you raise it to the power m individually because they have different bases. Okay? So this is the final expression. Okay, let's look at rule number 6 in indices. A raised to the power 0 is 1. Okay, in indices, anything raised to the power 0 is 1. For example, if you have 2x raised to the power 0, the answer is 1. Okay, right. So these are some of the rules or laws of indices. Let's look at some exercise. Okay, are you ready for some exercise? All right, exercise number 1, question number 1. Let's do this. A divided by b, all of this raised to the power m, times a divided by b raised to the power m. Look at this problem. Who can solve it? Which law of indices are we applying? Who can notice anything? Okay, look at this problem carefully. In this situation, we realize that we have the same base, right? So in indices, when the bases are equal, you just add the powers. You add the powers. Okay, let's say this is m so that we can see the difference. So we say, sorry, I want to put that clearly. This is m. Okay, good. So in this case, the right procedure or the solution is a on b divided by b raised to the power m plus n. M plus n. The bases are equal, and then we add the powers. Okay. Now let's look at question 2. The next example. Let's look at something. 5a to the power of 10, right? B to the power of 6 times 8a square, 8a to the power of 2, b to the power of 3. Okay, and let's divide this, let's say, by 4a, right? 4a to the power of maybe 7, b to the power of 2. Who can try to solve this problem? What is the solution? Look at the problem carefully. In this case, let's group like terms together. Okay, let's group like terms together. In other words, we can write this like 5 times 8, right? Times 8. These are like terms. Times a raised to the power 10. Look at this. When we what should we do? This is a raised to the power 10 and a raised to the power 2. So we add the powers, right? Because the bases are equal. Plus 2, right? And then b, since the bases are equal, also equal, we add the powers. B raised to the power 6 plus 3, right? And all of this divided by 4 raised to the power 4a raised to the power 7, b raised to the power 2, right? So we can further simplify this as 5 times 8 is 40. 40 a raised to the power 12, right? 10 plus 2, 12. And times, okay, times. We can say times, or we just write b raised to the power 9. 6 plus 3, 9. B raised to the power 9. All of this we divided by 4 a to the power 7 and b to the power 2, of course, times, okay, which we further see. Let's look at this. This is 4 and this is 40. 4 can go into, if you want to divide 40 things to 4 people, how many will you have? 10, right? So this one we cancel, okay? So if we do the cancellation here, we will have 10a to the power 12, right? 10a to the power 12 minus 7, right? Why are we minusing 7? Because we have a 12 and the bases are equal, so we minus, we subtract the powers, right? And then times b 9 minus 2, right? Which is equal to 10a to the power 5 b to the power 7. This is our final result. Okay, everyone? So this is how you can simplify this expression. These are the rules of indices. Okay, now let's look at some more questions. Okay, let's write everything on our screen. Let's say you have a question like this: 25 raised to the power 1 raised to the power half, right? In indices, when you have something like this, it means the square root of 25, right? Which is equal to 5. You might be wondering, teacher, how do you know that you have to? The problem is the square root of 25. How do you know that, teacher? In indices, when you have, for example, a raised to the power x of y, right? This means whatever the base is, the cube, the square, or whatever the base is, you take y, which is y, the cube root of a. Cube root of a, okay? So in this case, what do we have here? We have 25 raised to the power half, right? It means the square root of 25. The square root of 25. This is another law of indices, okay? This is a law of indices. Okay, now let's look at another problem. Let's look at 9 raised to the power minus 2. Just for example, if you have something like this in indices, we have to remove the minus, right? So to remove the minus, we say 1 over 9 to the power of 2, right? 9 to the power of 2, which is equal to 1 over 81. 9 squared is 81. That is the final result. Okay, everyone? So student, we are going to end here for today. I hope you have enjoyed the lesson. Okay, and we will continue again in our next class. Thank you for now, everyone. Goodbye.